So we're continuing our session on high-performance data analysis, and we'll have talks from SAS, from Shane Corder from Children's Mercy Hospitals and Clinics in Kansas City, and then also from Jack Collins from NCI. Starting with Charlotte, we've been tracking pretty closely commercial customers that are kind of moving up to HPC-like structures for analytics that enterprise technology alone can't handle well. And so that's why we asked Christine to talk here today.
Okay.
Go ahead,
Thank
Charlotte.
you. Thank you. All right. Okay. So I'm Charlotte Crain from SAS, a Principal Solutions Architect, and I live just down the road in Gig Harbor. So they said, hey, why don't you come up here and talk about high-performance computing with some of our commercial customers? And I said, sure. So one of the things in terms of when we're at our customers, and as you know, we got to ratchet it up here a little bit. So this isn't in the weeds, so I hope you guys aren't going to be disappointed. And this is more about business and what we're encountering, what Steve had said in terms of HPC. And if we just take a look at the data and just start there, which is foundational, right, to anything analytical, anything reporting, anything you want to do, it's all about data. And historically, right, we're sitting on legacy systems, we're sitting on servers, a lot of networks, but data historically has been, hey, we'll throw it here, we'll throw it there, and we'll throw it over there, and nobody really thought about 30 years ago about where we are today. How could they? And so we have a lot of legacy systems, and we have databases that have been built out now for the last 20, 30 years, and it is what it is. So in business, then, we get to deal with where the data is today, and also the customer's looking at where do I want to go in the future. So how we view data today and how the customer is viewing data today is more as a corporate asset versus just data sitting in that silo over there or this silo over here. And in having a different view of the data as a corporate asset, this is going to give them the competitive advantage that's driven by the market. It's also going to help them with risk in terms of auditing and compliance and financial performance, build better models. Can I get better financial performance? And also the need for simple and complex analysis. So simple complex analysis could be, well, let's do mean, max, sum. Let's look at histograms of our data. But, oh, by the way, relative to me, the company, my data is big. And that's a relative term. You know, it could be petabytes for somebody, but somebody else is terabytes. So when we talk about big data from a commercial perspective, it's relative to how the customer perceives what big is for them. And also in terms of the complex analysis, like, and again, this is driven by the market. Right? So we need to know who our customer is better, faster, and we need to encompass other data sources in there so we really know holistically who's our customer. And that requires far more complex analyses. And also, as has been previously mentioned, the Internet of Things, the connectivity of devices on the Internet. How are these things playing into the commercial space and in terms of the types of problems that SAS is trying to solve? So the end game is, right, to operationalize analytics faster, to stay ahead of competition. I think that's something IDC said. So that was what the business hat said. Now IT is sitting there and saying, well, that's great. We've got growing data volumes. We also have a lot more sources, and we have shrinking IT budgets, and we have a stagnant skill set, maybe. We have financial considerations because of our shrinking budgets, and we need to do more with less. And also they're tasked with deploying perhaps more sophisticated analytical models, which by definition are going to require more compute processes. Business requirements change quickly with other things that are happening, say in healthcare, for example, with state mandates, is that there are types of business requirements where this is the way the payment's going to look, and by the way, this is the way it's going to look this 4 months, and in the next 4 months it's going to look this way. And so the businesses need to be able to adapt quickly, and IT needs to follow along and to be able to support that. So IT is sitting there overwhelmed, like we've got to be able to do these types of things, and here we're kind of strapped with our current infrastructure. What are we going to do? And the cost to maintain our legacy systems, that's a big elephant on our back, and what are we going to do about that? And it's also a risk to the bottom line of the business because it's IT's job, right, to keep the lights on. So staying in the game together, what are these folks going to do? So again, business simultaneously needs to keep pace with demand. IT says, I need to meet my SLAs and meet my business requirements. Business says, I've got to have a compute process that can be consistent, reliable, and trusted. And trust is a big deal when it comes to the business side, because they have to be able to know, like, if I'm going to go and build my model, and we've got an initiative here at our company, we need to be able to do these types of things. Can IT deliver? And when that relationship as a business takes hold, where business and IT are working together because compute is satisfied, because IT's found a way to do high-performance computing for the analytics that the business folks need, then you have a very competitive organization. So just talking a little bit about the types of grids that we have at SAS and what we've been doing at our customers. So customers, we're encouraging them to be the best and outcompete your competition. So today we have essentially 3 types of high-performance computing. We have the grid computing, which is the typical scale out, a lot of commodity servers. We have in-database, where we actually push the analytics to the data. And we have something called in-memory. And this is in-memory analytics. This is not a database. This is an in-memory analytics server. So the high-performance grid computing, this again is going to pretty much take what you have. And in the case where IT says, hey, I'm really budget constrained, well, can we add to that? Can you just take commodity hardware? And can you scale out versus scale up? Because sometimes it's much easier to do a business justification for scaling out because it's cheaper and I can do it incrementally versus scaling up. I got all this big server, and then what do I do when I needed to get the next one? And so with the grid computing, this is where you get your scheduling, you get your high performance, your failover, your redundancy, and all that managed through the grid computing. And of course, why it matters. Again, as I mentioned earlier, they use the commodity hardware to reduce costs, distributing and managing the load across those servers. And again, the high availability. So in terms of a process or a stepwise progression, is a lot of customers will go to this type of grid computing. It's a cost reduction to them, and they're using their existing hardware or adding on a few other servers and go buy 10 commodity hardware or commodity servers and throw Linux on them, and you're good to go. Essentially, it is about that easy. And at the same time as reducing costs, we're reducing our compute time from literally days and hours to minutes. In database, this has been around for a while, and in terms of what it offers, the administration management, we're pushing our models, the analytics to the data. So in terms of security, if you think about PII or think about big data, you certainly don't want to move that, because from a performance perspective, right, that's the biggest hit. I got to move my data first, and then I got to go do something with it, then I move it back, and that really is not desirable. So we move, as I said, the functions into the database, and we utilize the database processing power because they're typically bigger boxes anyway. Faster time to results. So let's be able to just, if I've got a billion row table, and this actually just came up on a customer call last week, a very large entertainment customer who says, well, hey, I've got a billion rows of data and I want to be able to score that. Can you guys do that? Like, sure, we sure can. It was on Teradata in that case. Run existing SAS code without modifications and running on all the data. And this is really important. And again, like I said, leverage the existing database architecture. The in-memory analytics, this has been around now for a couple of years. So essentially what happens is we lift the data in memory, and at that level then compute, or we can do a ton of visualization. So I heard some ESP stuff, and I'll talk about that in a little bit, but just in terms of visualizing your data, and how do you know what you have? How do you find out what you don't know? And so this is a way where we have actually smaller customers and very large customers use the in-memory analytics server for data visualization. But we also have the high-performance analytics that go with that. And so there's essentially a public and a private way that you can use the in-memory analytics server. From a private perspective is that I'm the analyst. I load my data into memory, I run my algorithms, I do my compute, I get my results, and then what I do is I can move the data, take the results, and drop it into, say, Hadoop, and I can shut down my memory. From a public perspective, I can load the data up, and let's say it's a huge table, maybe a terabyte of data, and you've got business users, and this gets a little dangerous, but it's like, oh, I want to go look at the data, and everybody wants to look at it a little bit differently. So everybody can use that same table. So this is where, in terms of business, is that, and in terms of the visualization, this has turned out to be a really, really nice solution for our customers. And again, as you can see, banking, retail, and a lot of different domains out there in industry that are looking for this type of solution. And of course, why does it matter? Kind of like what I've been talking about before. One of the things that we've really looked at a lot this year has been our capabilities in Hadoop, only because Hadoop has been much, much more mainstream and a greater adoption, even though business is still in its phases of adopting Hadoop, is there's a lot of functionality that we have in terms of where we can process in Hadoop, or to, if it's stored in Hadoop in a special format, we can rapidly lift that into memory. Okay. So with all that being said, though, business still needs to have accuracy. Again, I have my business hat on here. And again, it goes back to the data and all of the capabilities that we have. And in terms of analytics and in terms of accuracy, it all goes back to the data and how accurate is the data. So having done analytics for 37 years, we're actually pretty good at having accurate data as well. And complex data, and I've heard from the folks at PayPal and where, from the Internet of Things, where this data is coming from. It's getting more and more challenging, right, to be able to piece together that information in a very good quality way to provide a basis on which we can do analytics. And then in the scalability here, just in terms of being able to scale out as needed and maximize the current infrastructure. So if you have Hadoop, great, we can work with that. If you have databases, great, we can work with that. So it's a step over to high performance computing, because they can't get to where P&L is right now, right? They're not going to get to what PayPal's doing right now, even though they might like to. And we've had customers ask us, like, well, we want what Google does. And just like, well, do you want to pay $1 billion? Well, no, but we just want to know what you can do anyway. So we get all kinds of questions, as you probably can imagine, from the business folks, and that's okay. Governance, in terms of whatever you do in terms of analytics, if you have a governance process in place, and again, governance means things to different people, but in terms of business here is that IT's got policies around data, who uses it, what are the data definitions. This is old stuff, it's been around for a while, but as far as actually implementing it and actually have a good governance programs, because that translates into I have good data and good data quality, so my analytics is going to be really, really good. And that, again, this is all kind of playing together, but that's the state of business today. And they're moving as quickly or as slowly as they can, but it's all recognized these are must-haves in terms of business, and obviously economics driving the bottom line by reducing the total cost of ownership of the types of architectures that I talked about. So looking at the options here from what SaaS has to offer, we have at the enterprise level here, we have the SaaS grid, which is essentially the structure that I talked about earlier, where we've got a bunch of commodity hardware, and we could, you've got the Hadoop cluster there as well, we could take the data, if we have to move it, and move it into the SaaS grid. Or we could move it from the Hadoop cluster into the SaaS rack. And the SaaS rack is the in-memory component there. And there's different types of capabilities up in the SaaS rack there. We've got high performance, this, that, and the other thing. But there's also, just in terms of visualization and running analytics, there's also this visual type of statistics now that we can do as well. So building a model inside in memory, in the in-memory compute server, is that I can now visually, what I used to code and do my regression models or do logistic models or whatever it is, I can actually do this visually. So I can do my VA, I can do my visual explorations. I can say, hey, I like this, and I've got X number of whatever observations I have, and I can grab those and I can throw those in now, and I can develop a model. Then I can easily look visually, what does my model look like, what do my model stats look like, that sort of thing, and I can go back and forth. So that SaaS rack environment in terms of analytics for customers and in terms of getting some high power out of leveraging the in-memory capability is turning out to be quite nice. The EP that you see down on the right-hand side in the Hadoop cluster, what that is what we call our embedded process. What that is that we can have SAS code, it's called DS2 code versus, we call it second generation SAS code. And we have this EP that we push into either the database or we push it into the Hadoop cluster, and so we can run the logic, do the math on the Hadoop cluster. And again, this eliminates some of the data movement. So let's look at some trends today. So if we go out and do a Google search and we look at analytics and we just want to see how many hits we have, is that you can see from the graph here, just from 2014 today, it's not getting any less, let's put it that way. If you do the same thing for big data, again, sort of a relative term, but you see that only in the last, say, 3 years, that the phenomenon of big data has really taken hold in business. If I look also for what's going on with Hadoop and what are people Googling on in terms of Hadoop, it also has a huge increase just even in the last couple of years. And what's driving this, is particularly Hadoop, is what we talked about in terms of many, many different types of data sources, the Internet of Things. I've got my devices, I've got social media, I've got my Twitter feeds coming in, and I want to capture some of those. Where am I going to put this? What should I put in Hadoop? And if I, again, look at the Internet of Things, then that also has been increasing, actually exponential. It's an amazing graph there. So if we look at all of these things together today, and business is looking at all of these things together today, we have what we term here at SAS called the era of abundance. So we have a lot of cheap storage. We have a lot of things going on in terms of the Internet of Things and devices. This is our big data, if you will. The thing is we've got 2 eras. So the first era that I talked about earlier was where are we at today in business? Legacy system, we've grown up with these. We really want to move to a better environment. We really want to be able to modernize our business. And I'm still stuck in old school. This is normal. This isn't a bad thing. It's like it is what it is. And this is where we come into the customer and start talking about is where would you like to go? Can't boil the ocean. Got to get there stepwise. But still this whole mindset of I've been doing this for 20 years and this is how I think about my problem versus say the folks like at P&L and PayPal, and they're over here in the abundance mindset, as are some of our customers and many of us in the room here, obviously probably all of us, in terms of abundant mindset. It's just how do I think about the problem? And so in scarcity mindset, they're focused on constrained versus empowered. The scarcity is focused on process versus discovery. And we're focused on cost control in scarcity versus value. And on the scarcity mindset, the DBAs are just like, unless you need it, everything's off the table. And in the abundance, give me everything unless it's forbidden, maybe in terms of security or some reason like that. So those are very, very, very different types of mindsets. And when you look at this picture here in terms of how am I going to solve my problem, right, is that if I don't have an abundant mindset or willing to go over to an abundant mindset, I'm really going to be stuck with my legacy system. I'm going to be stuck with high-performance computing issues if I don't start to adopt an abundant mindset. So the era of scarcity, what does that look like? Those of you who are in business, you probably have heard this, know about this, read about this. This is what we could easily hear from IT over, over and again. So they're spending a lot of money on storage. They're limiting the data software access to the few, which is a huge, huge problem on the business side of the house. My staffing resources are gold because cost containment and SLAs, and they have a certain budget to follow. So the first 2 bullets here is that I put my business hat on and I'm asking these questions because I've sat and talked to researchers, I've sat and talked to a lot of folks who are on the business side of the house, and they say, I spend a lot of time creating workarounds, and they build these little data marts for analytics because IT only gives them so much. And then what happens is that IT, it says, provisions the data, but not data that I need. So then on the business side of the house, what happens is they say, oh, I need to build a new model and I need 10 more variables, and oh, I forgot to ask, I didn't think of it last year. Gee whiz, why didn't I? Now I need to go back to the well, to IT, and ask them for this data. That means fill out a requisition, get all the requirements. It goes over IT swamped, they don't have enough resources. 3 months later, literally, the business gets their data. This is the reality of what we run into day in and day out at business. It is what it is. Not a bad thing, but it can be fixed. And so in terms of, if you think just in terms of impact of business, if the analysts there have really good ideas and they want to have a business strategy and they want to have some initiative and they literally cannot do it because they have a data prison, what's suffering? I mean, how can a customer even be competitive in that case? I mean, we've talked to healthcare groups that said, hey, we wanted to do like 100 of these different types of modeling initiatives that they had. They did 20. And the problem was this whole process around data and building models. And it continues. So I need to maximize my storage efficiency. Using new sources of data for analytics is impossible. That's the scarcity mindset, because the new sources are really not possible because I have my existing warehouse and it looks like this, and it's going to be too tough, right, to get the new sources into my warehouse. So sorry, we can't do it. It is what it is. And also the approved tools on the corporate standards list is shrinking drastically. It's like, well, that could be, and it could be on the business side for trying to do analytics. You get this bucket of tools, and they do what they can. I have met the most amazing people in business and on the IT side of what people do with what they have. I mean, human beings are just remarkable. It's just amazing. And I just am in awe sometimes when I see the types of problems that are being solved with the tools that they have. And of course, when we come to site, we would like to, have them use some better tools or easier tools or maybe more robust tools. But again, today, this is where we're at. And a lot of companies are making great progress in there, and there's a long way to go for some others. And then in the end here is that because of all these delays in the whole era of the scarcity piece here, is that we've got products that the company finally gets something out the door, they're late to the market, then they spend a lot on marketing, and then IT still is what it is. They can't develop new folks because they're still trying to keep the lights on. And it's just this vicious cycle that goes over and over again. So in the era of scarcity, what if you could take cost and scarcity and you could replace that with value and abundance? And you say, okay, well, why? Why should I do that? Why should I support more users or form new partnerships or collect more data? That's hard stuff. I need to adapt. Oh my gosh, I need to change my way of thinking. And as we've heard earlier today, it's all about the new paradigm out here of what we've been experiencing with the internet. So now today we can wear a heart monitor, right? And that device is emitting data back to the company that has it or that's keeping track of that. We've got smart thermostats in our house that are feeding information back somewhere so that somebody's keeping track of that. We've got the smart grid, right? That's smart out there telling you when your refrigerator should kick on full force so I can manage my peak energy load demand throughout whatever service region that I'm looking at here. And then we've got the Facebooks, we've got the Twitters, we've got the blogs, we got the bookmarks, we've got Delicious out there. We've got all kinds of things that are constantly going on, and they actually relate to business. And so in terms of this whole explosion of data, that's why, if you're going to stay in the game at all, is to be able to get out of that scarcity mindset and start being creative and thinking about solutions in terms of computing. So the scarce approach here, if I have my consumer lens and I look at, how do I look at my consumer? I may say, okay, I know enough about them, I can give them in-store rewards. Maybe I know their prescriptions, I know maybe the kind of energy drinks that they have. And if I'm looking from the health perspective, it's like, okay, they wear seatbelts and they have a gym membership and so on and so forth, and maybe they like certain types of sports. And then I look at maybe the risky behavior that they might have. Maybe they're a motorcycle driver and they got 2 traffic tickets or something like that. But what if? What if I could put on my abundant hat and look at the entire lifestyle together and look at all of these different characteristics together? Would that change the risk score? Would that change the way in which I can view my customer? Because the old way is silo 1, silo 2, silo 3. I'm doing my campaigns on each of these. Over here in the abundant world is like I'm bringing all of this information together because I can, because I have the storage, because I have the compute capability to be able to actually act on that data if I can even get it together. And so show me the money. So some customer use cases, not by name, but just in general here, is that customers buy software for typically 3 reasons: to save money, to make money, or to stay out of jail. In the first case, we have leverage all sensor data for improved asset reliability. So currently, at a very, very large oil company in the world, they have tens of thousands of wells, and there's sensors on these wells, and they've got data coming up. And so we have our own ESP, Event Stream Processing Engine, that takes a look at that, and we can look at what's normal and then create an event that's some outside of the scheme of what we consider normal. And so we can build out a model, what that should be, or what we call an event. And then so the ESP can come in, and as soon as something happens that's outside of that range, right, boom, they know that. So in terms of that well point down there, waiting, right, for a day or 2 or whatever, they're going to know immediately, which is kind of, I think, what PayPal is talking about too, in terms of we know like right now. And so the ESP capability is pretty amazing. In fact, it's our 3rd ESP, and the developer of our ESP engine has built 2 before, and he says this is by far his best, and it is super fast too. Evaluating risk, this is like fraud and detection. As you probably know, is that SaaS is huge, right, on analytics and fraud. I'll get to the last one. I have 1 minute left. Personalized product and content. Right now, we have a huge retailer, and again, we have our streaming data coming in. We have the mobile app, and I'm walking around the store, and it's like, wow, I really like what I'm doing there. But we can tell, Big Brother here can tell, okay, I'm me in the store because I have the app. And by the way, what I'm looking at, maybe I'm looking at pet food, and they go, hey, I'm going to give you $5 off that pet food. And then over here in the store, there's something else on sale that might be related. This is currently one of the applications that we're doing. So how are we going to do this? How can we scale? How am I going to reduce costs? Let me flip through this really fast. So this is the old way of doing things, where we essentially have the ETL, and then we pull the data out, pull it into SaaS, build the math, push the score back into the enterprise warehouse, and then we can service our end users. Or we can look at the new architecture here, where we have the same back-end operational systems. Maybe now what we do is we take the data and we perform some analytics, and we can say we shove some of that data in Hadoop. We can actually push now the math back into the operational system, push it down to the database. We can also, so we push it backwards into the database. We can also push it forward into the warehouse there. So both places, and we can also then even get smarter on the back end of our applications of how the end user would consume the decision. So just some food for thought. What we talk, and when we're talking to our customers, it's like, what is their mindset? What can you do today? What are your faster, better ways, and so on and so forth. I think that's about it. Thank you.
Thank you. One kind of starter question. As you know, I've talked in depth with some of your customers, and one of the patterns that I saw that sort of surprised, intrigued me is, for example, one company, a global company that does, I won't name them, that does credit reports on lots of other millions of companies, and maybe a few years ago they had to update those once a month.
Yeah.
Now they got to do it several times a day.
Yeah.
And they've moved to your grid product and so forth because they couldn't anymore do that with what they were using before. And I said to them, well, what would you have done if you couldn't make this move? And they said, we would have had to go from deterministic ratings to heuristics. And he said, that would have broken our business. So I guess what I'm seeing is that this is a continuing thing where they're having to push upstream to remain competitive.
Absolutely. Absolutely, yeah. And this is the whole decisioning, right? A whole decisioning science around this in terms of if I've got the analytics already built, at the deployment level, where can I deploy that? And that kind of gets into a bigger conversation, but yeah, absolutely.
Other questions from the audience? Or from the panel? Okay. You did a good job.
Oh, I don't know, maybe.
Thanks again.